Today we're going to be taking apart the center display assembly on a European model Honda Civic Mark VIII. This model was manufactured between 2006 and 2011. Here you can see the problem with the faded out display. When the problem first started, my instinctive reaction was to hit it, and this did in fact fix the problem, though only temporarily. The fade out has been getting progressively worse, meaning the time between it displaying correctly and fading out again has been getting shorter and shorter, and the problem is extremely annoying. Why am I doing this myself? Why am I not taking it to Honda? Well, I'm pretty certain that Honda's solution will be to replace the entire display. The display part in question costs £445. That price is from Ling's Honda as of May 2021 and is for a brand new, genuine part. I wouldn't get that much for the whole car if I traded it in, so I'm going to fix it, not replace it. To do this fix, you'll need some plastic spudger tools or similar, a screwdriver, a multimeter, soldering flux, soldering iron, solder, isopropyl alcohol, and the ability to not lose your temper with some really awkward plastic clips. To get the audio display out, we're going to have to remove the speedometer cover, the speedometer display, and the large flat plastic panel in front of the audio display. The speedo cover is by far the easiest part to remove. Just grab hold of it and lift it upwards. The flat panel is significantly trickier. All of the components that we're going to be removing are primarily held in by plastic clips which are designed to be easy to install and then to not come loose or fall out, meaning they are very awkward. It is a delicate balance between using enough force to get the damn things out and getting the technique and control right so that you don't snap any of the plastic. Work your way around the large flat panel, starting from the left-hand side. With the panel removed, there are two Phillips head screws which also need removing. I took out the speedo display next. This proved to be very difficult, and I've cut out the struggles that I had with getting it free. Basically, you just need to pull it forward and very slightly up, but this is much easier said than done. Now it's time to get at the actual display that we want to remove. Again, this is awkward to do. It requires quite a bit of force at the same time as not wanting to damage the display or the fixings. It is a question of perseverance and keeping your frustration in check. Maybe you'll be lucky and you'll have the technique right from the start and you won't have a problem, but I had a hard time getting it free. With the display out, disconnect the wiring harness. Now we get to look inside and figure out what the problem is. Firstly, take off the black front panel. This is held on by a number of clips all around the unit. Once again, you are dealing with some stubborn and flimsy plastic clips, so try not to break any. You could probably leave the black front on, but I prefer to take it off so you can lay the unit flat and it is easier to work on. Now remove the back of the white unit. This is much the same as the black display. The actual problem which is causing the fade out on the display is that power is not making it properly to the LCD. The power comes to the unit via the wiring harness. It then flows through the PCB and connects to the display via pins at the bottom, which pass through holes in the PCB and are soldered onto connection points. The solder joint between the PCB and the pins has failed. This means there is a crack or a gap in the solder joint which prevents electricity from flowing properly. This also explains why hitting the unit actually made it work, although only temporarily. The vibration from being hit created movement in the board and made the 2 points connect again. That is until another vibration from driving breaks the connection. To fix this problem properly, we need to reflow the solder and add new solder to any connections where there looks to be an insufficient amount. To reflow the solder, I first apply some flux with a small brush. Flux helps the solder flow and protects against oxidization. Using a hot soldering iron with a fine point, just go along touching the tip of the iron across each connection point. You want to make sure that you make contact with the pin, the solder, and the connection point on the PCB. Hold the tip there just long enough until you see the solder melt and reflow. Work your way along all of the pins. Add additional solder to any points that need it. Clean the area with isopropyl alcohol and a Q-tip to remove any residual flux. You can use a multimeter set to continuity if you want to check the contacts. Test between the testing point on the PCB and the corresponding pin. Reassemble the unit and the dash of your car. Now it is time for the moment of truth. Success! I actually filmed this repair in April 2018. It is now more than 3 years later, and I'm happy to say that after this fix my display never had any more trouble and is still working perfectly today.